Hello, everyone, and I am very excited to present our work Unsafe2Safe, which is a framework for controllable image anonymization with downstream utility preservation. This work was done with Professor SouYoung at Dartmouth College and was accepted as a highlight paper at the CVPR 2026. The goal of our work is simple. Given an image, we want to remove privacy-sensitive information while still preserving the information needed for downstream tasks. Traditional anonymization methods usually first detect faces and then blur them. Moreover, recent diffusion-based approaches can even enhance this area and offer controlling on attributes such as emotion, pose, or other face characteristics. However, all of these methods are still fundamentally constrained by the detector. Detectors work well for obvious concepts such as faces, bodies, or clothes, but privacy is often much more contextual. For example, they may miss cultural cues, hobbies, socioeconomic background, or, for example, inside the scenes, confidential documents. To address this drawback, we propose detector-free privacy using vision language models. Instead of relying on predefined detector categories, the VLM reasons about privacy directly from the image context, while diffusion models perform semantic-guided editing without segmentation. Our framework consists of two stages. In stage 1, the privacy filter VLM first determines whether an image is safe or unsafe. If the image is already safe, we keep it unchanged and directly use it for downstream training. Otherwise, the image enters the anonymization pipeline. The captioner VLM first generates a private caption describing all visible content in the image, including the sensitive ones. Then, it generates a public caption where identifying details are removed or neutralized. The public caption provides a generic semantic canvas for editing. Based on this public caption, an LLM generates edit instructions describing plausible alternative content that still fits in the scenes. Finally, we combine the original image and these captions to guide an image editing diffusion model, which synthesizes an anonymized alternative image. The original unsafe image can then be discarded, and only the anonymized version is used for downstream training. Here are some qualitative examples. As we can see from the images, previous anonymization methods mainly modify the face region while leaving the surrounding context unchanged. As a result, sensitive information, such as confidential documents, may still remain visible. In contrast, our method performs more holistic anonymization by modifying contextual privacy cues when necessary while still preserving the overall scene semantics. For evaluation, we propose to benchmark three aspects: utility, tuning, and privacy. From our experiments, we preserve downstream performance while substantially reducing identity similarity and textual leakage, as well as promoting more uniform race distribution. To conclude, privacy issues are often not easily segmentable. We argue that privacy preservation should not rely only on detectors, but instead require contextual reasoning about the entire scenes. By combining VLMs, LLMs, and diffusion models, Unsafe2Safe fosters more flexible and comprehensive anonymization while preserving downstream utility. One limitation of our current framework is that it still depends heavily on off-the-shelf models, including their bias, reliability, and generation quality. Extending this framework to specialized domains, such as medical imaging, also remains future work. And finally, although our framework anonymizes people in the images very well, users still know the people behind the paper, which are me, Minh, and Professor SouYoung. Thank you very much for your attention, and please feel free to visit our webpage or GitHub for more information.